Hi class, this is number 2 on 7.2. In an election, suppose that 35% of voters support a school levy tax. If we poll 103 of these voters at random, the probability distribution for the proportion of the polled voters that support a school levy increase can be modeled by the normal distribution pictured below. Complete the boxes accurate to 2 decimal places. So it looks to me like they want us to, come up with the mean. And it looks like it's right below 2 standard deviations below the mean, but I might be wrong. So, or I'm not quite sure whether they want us to do the 1 standard deviation here, because the box is normally 1 space over would be 1 standard deviation below the mean and 1 space over. So then the box is located kind of right on top of 2 standard deviations below the mean. So I'm not quite sure, but we'll figure it out. So how do we to solve this problem? We need to find the mean and standard deviation of this distribution. This is the distribution of the population proportion, or they call it a sampling distribution of the population proportion. So the mean of this distribution, they mu, they use this U symbol, and they do sub p hat. Okay, so mu sub p hat is equal to, and are you ready? It's equal to just the population proportion. And this is kind of an obvious fact, but here's your population proportion. 35% of voters are for some whatever school levy. That's our population proportion. And if we did lots and lots of samples of size 100 and 3, most of those samples are going to come back with 35% of them being for the school levy, because the entire population is 35% of the entire population is, is for the school levy. So if we took lots and lots of samples and we recorded what their population proportion happened to be, a lot of them are going to be reflective of that original, of the population. Okay, so this is 0.35 right away. Of course, it's 35%, and of course, we never put those in we'd never hardly ever put these numbers as percents. We always write them as our percents as decimals, right? Okay, so that's the first part. And then the sigma p hat, so the standard deviation of the sampling distribution of the population proportion, this is equal to, and there's a formula, it's not too hard, and I put it up here just so, and actually see, here's the 2 formulas that we really need. Is P times 1 minus P all over N. Now, actually, just so that you know, if they say that there's a population proportion and they wanted to do a distribution of the sampling, a sampling distribution of the population proportion, like so, we could not just assume that it's normally distributed pretty and normally distributed like that. We couldn't assume that. We would have to check, if this requirement that N times P times 1 minus P is greater than or equal to 10, then we can assume that it's normally distributed. For this particular problem, they just say it is. So we're just going to accept it as fact. Another thing that we have to check with these types of problems before you were to actually do calculations and stuff like that is that you have to make sure that when this voting was taking place, that it's independent. That means when I picked one person out of the population to be part of my sample, I had the same likelihood that they were going to be for the school levy as the second person. Technically, that's not true. Technically, if I pull one person out of the population, let's say I pull one school levy increase person out of the population, now there's one less person. Now that it's harder to find a second person because now that there's just fewer people out there for the levy because I took one out, right? This is when we do sampling, it's without replacement. So technically, it's not, but what they say is if the sample size is so much smaller, is a lot smaller than the entire population, then taking one person out of the population doesn't really change your probability of getting a second person who's for the school levy, because it's such a large population. Taking 1% out barely makes any difference, So that's why they say the sample size has to be like less than 5% of the population or something like that. And that's what's meant by here. Your sample size has to be less than 5% of the population, because if that's the case, then like I said, then we would call this an independent we would call it independent trials as far as when we're picking people to be part of our sample. All right, but we're not going to worry about either one of those things with this particular problem. But let's get down to the gritty of finding these unknown boxes. So now I just plug in the population proportion, this P. Okay, P without a hat on it, that's the population portion. That's the percentage that they give you in the problem of people who are either for something or against something or described in the problem. That's the population portion P. Then P hat is the population proportion coming from a sample, okay? So if they told you, oh, we took a sample and 35% of the people in this sample were for or against something, then that would be a population, a sample proportion and not a population proportion. But this one, they're presenting it as a population. They already pulled the whole population and they already know 35% of them or have a certain particular thing, okay? All right. So plugging in for here, I have to do the square root, and this is a big complicated kind of problem. And so you just have to know how to follow your order of operations closely here, but I plug in P, which is a 0.35. Remember, I never put a decimal, I never put percentages in, I turn my percentages to decimals. Okay, then 1 minus 0.35, I'm sorry, 1 minus 0.35. And then all over n, which is 103 right here. I put this all into my calculator. I've been using ClassCalc a lot. So let's get ClassCalc up, CLA. And then once you put it in your calculator, once you type it into your Google once, mine just remembers it. So I just start typing CLA and then it just comes up for me. I just want it to do the square root. So you could either type in square root Oh, there's a square root symbol. So I put in square root, and then I can do in parentheses the 0.35 times 1 minus 0.35, or you could just put 0.65 to simplify this. This can be kind of complicated to put into a calculator, actually. I don't like it. See, I need all of that stuff to be in the numerator, not just this 0.35 is also in the numerator, not just in the denominator. So let me try to get out of it. Maybe if I highlight all of this, well, anyways, I can. Or maybe the best way to do this, I think if I could highlight all of this, it'll let me. Then it's easier for me to divide all of it. Oh, I need to put another parentheses. That's what's going on. Now press divide. Now I have it right. Okay, 103. It's got to have, see, the way I had it before is it wasn't, with all of that needs to be in the numerator, right? If it's not, it's probably not going to calculate correctly. So they're giving me the answer here is 0.04699. I probably want to keep this accurate to at least 4 decimal places or more than I need in my final answer. 0.0469, 0.0469. Okay, so now we need to take the 0.35 and add 1 standard deviation, this 0.04, so the 0.35 plus 0.0469. So that gives us 1 standard deviation above the mean would be this. And I think that's really what they're asking for here, but I'm not positive. So let's double check it. Cool. And then on the other side, I take 0.35 and I subtract the standard deviation. Borrow from the 5, make it 4, 10, make it 9, 1, 3, 0, 3. So I believe those are the ones they want there. Let's just double check the answer. And I believe I may have, I don't know if, let me just, oh, because it's way down here. Oh, it is. Oh, this one's a slightly big different problem, but let me just check the answer with this one really fast. It was, I want the one that had 103. Let me see if I can get back to the one that had 103. Okay, so just so you know, this is actually 2, they do want us to go 2 standard deviations, not 1 standard deviation. That's why this box is like centered above this little tick mark here. So it's not 1 standard deviation like I thought it may have been, but it's actually 2. So that means I have to take, it's not this 0.3969. I have to take and add another standard deviation on to get me to 2 standard deviations above the mean, and then I'm going to get my answer. So it's 0.44. Wait a second. Okay, at 0.44 here. So then they want you accurate to 2 decimal places, so you just do 0.44 here. And then the other side, you have to take away another 0.0469. And you do divide by borrow, 2, borrow. those are your answers. All right, well, I hope you found this very valuable. Be careful putting this into the calculator. It's best if you put it into TI-84 calculator and you can confirm that it does look exactly like this. Sometimes the graphing calculators will like draw a picture of what it is that you're entering, and that kind of really helps you, know that I did put it in correctly, right? Because like I mentioned, if you put 0.35 and then you times that by, actually you're gonna get the same answer if you do that, but like as you do, the mistake here that some students would make is they would do the square root of just the numerator part. And then they would take this answer and then divide it by 103. But no, the 103 has to be under square root as well. And so it's best just to do this all in one thing in your calculator. All right. Let me know if you have any questions. Have a great day. Bye.